Welcome to the AXA Engineers Podcast, episode 14. Today, we're embarking on a really crucial deep dive. We're looking into a topic that, well, it's often overlooked, but it holds immense power over the success or, unfortunately, the failure of civil engineering projects.
That's right. We're talking about those critical vulnerabilities in design.
Exactly. And crucially, how many of these challenges are not just solvable, but can actually be transformed, turned into opportunities for truly robust, efficient, and successful project outcomes. This deep dive is really tailor-made for you, whether you're navigating the complexities of civil engineering outsourcing, maybe looking to ensure project integrity, or just keen to uncover what truly elevates an engineering partnership.
And I think what's truly fascinating about today's discussion is our mission here. We're going to unpack some of the most common, yet surprisingly devastating, design errors, the kind that can plague the civil engineering industry.
But we won't stop there, right?
No, absolutely not. We'll then pivot. We'll explore the innovative strategies, the proactive solutions that leading firms like AXA Engineers are employing to overcome these very challenges. Our aim today is really to illuminate the positive, the trust-inspiring aspects of cutting-edge engineering services. We want to illustrate why a strategic partner really stands out in the civil engineering outsourcing landscape.
That's precisely it. We want to empower you, our listeners, with insights that not only highlight potential pitfalls, but also showcase the pathway to, well, unparalleled project integrity and, frankly, peace of mind. Before we really dive into the core of these insights, though, we'd love to hear from you. What are your biggest concerns or maybe your most significant successes when it comes to leveraging external engineering expertise, perhaps in civil engineering outsourcing?
Yeah, share your insights.
Definitely. Share them and make sure to follow us for more deep dives into critical industry topics like this one.
Okay, so kicking things off, this immediately brings us to what many in the industry consider the single most expensive assumption an engineering firm can possibly make today.
And it's probably not what people immediately think of.
Exactly. It's not, the fluctuating market or even unpredictable material prices, though those certainly present their own headaches. The deepest, the most insidious cost often stems from the belief that an internal review process, just on its own, is inherently sufficient to catch every single critical design flaw.
That quiet confidence.
Precisely. It's a quiet confidence that paradoxically can lead to just monumental financial and structural fallout.
Okay, let's unpack this a bit more because this isn't really about blaming individuals, is it? It's more systemic.
It's absolutely about systemic vulnerabilities.
We're talking about how seemingly minor oversights, those little details that might get inadvertently bypassed or, missed in a rushed internal check, how they can silently escalate.
And escalate dramatically.
Into multi-million-dollar recovery efforts. And in the worst-case scenarios, these same oversights can lead to catastrophic project failures.
And if you're operating within the realm of civil engineering outsourcing, these risks can potentially amplify. They can create unforeseen complexities across different operational models,
leading to significant liabilities down the road.
Indeed. The true danger often isn't that single glaring mistake that's visible to the naked eye. It's more often a subtle chain of overlooked design errors, each one kind of building upon the last like a precarious house of cards.
Right.
And this insidious chain frequently begins at the very earliest stages of a project, specifically with inadequate site analysis.
Okay, so right at the beginning.
Right at the beginning. Imagine for a moment a large-scale project moving forward. It's on ground that everyone involved believes is stable, well understood. However, maybe due to budget constraints or tight timelines or simply a reliance on traditional, less comprehensive methods, the geotechnical survey might be rushed or just incomplete.
So it's not just about getting some data, it's about getting all the right data and then interpreting it correctly. Missing one piece can throw everything off.
Precisely. That's the crux of it. This incomplete survey might miss crucial data points. We're talking about granular details here, like specific variations in soil composition, maybe the nuanced load-bearing capacity of different strata, or even subtle fluctuating hydrological conditions beneath the surface that weren't picked up.
Things that aren't immediately obvious.
Exactly. And this omission may be buried deep within early project documentation. It doesn't just sit there innocuously. It becomes a fundamentally flawed foundation, a kind of digital quicksand, if you will, upon which all subsequent design decisions are then built.
Wow.
Think about it. Every structural calculation, every drainage plan, every material specification is then based on an inaccurate understanding of the very ground the structure is meant to stand on. This initial blind spot becomes a silent saboteur.
That immediately makes me think of the domino effect you mentioned. If the foundation of your understanding is flawed, well, everything built upon it is inherently vulnerable.
Mm-hmm.
And here's where it gets really interesting and potentially damaging. This initial gap in site analysis often leads directly to poor drainage design.
It's a common consequence.
Because if engineers are relying on incomplete or inaccurate information about the subsurface, their hydrological models are bound to misjudge things, right? Like seasonal water tables, or underestimating peak water flow, or maybe misinterpreting subsurface flow patterns.
Absolutely. The model is only as good as the data you feed it.
So this disconnect between the meticulously drawn design on paper and the actual dynamic conditions of the site, it creates a direct, almost inevitable path towards severe structural issues down the line.
Yeah, you're setting up for problems.
We're talking about issues like, hydrostatic pressure building up against foundations, soil liquefaction, chronic erosion.
All of the above. And they can all severely compromise structural integrity. It's a critical vulnerability in any project, but you can see how it's particularly crucial when partnering with external engineering teams, say in civil engineering outsourcing.
Right, because that initial data exchange and having really clear communication channels are absolutely paramount there. Misunderstandings can creep in easily.
Exactly. And to truly illustrate the gravity of how quickly these seemingly minor oversights can spiral into a full-blown catastrophe, let's consider a sobering anonymous case study. This isn't theoretical. It's a real-world example of what unfolds when that most expensive assumption about internal review's efficiency really takes hold.
Okay.
This involved a mid-sized commercial development, and it encountered significant and, importantly, avoidable challenges.
So what was the first misstep?
The initial pitfall here was a classic one, really. It was driven by that understandable desire to optimize costs upfront.
Saving money at the start.
Right. The project management team, aiming to keep initial expenditures low, decided to limit its geotechnical investigation. This decision resulted in only a very basic soil profile being developed. And critically, an insufficient number of boreholes were drilled, just not enough data points.
And that seemingly small cost-saving measure had big consequences.
Profound and devastating consequences. It failed to detect a localized high-plasticity clay lens, situated directly beneath a critical corner of the building's proposed footprint.
You might think, oh, just a bit of clay. But as we've learned, ignoring those nuances of the ground can be like a ticking time bomb.
And that's precisely the insidious nature of such oversights. The structural and civil plans then proceeded, based on this flawed data. So they worked under the false, but completely understandable at the time, assumption of uniform, stable soil conditions across the entire site.
Because that's what the limited report suggested.
Exactly. Based on this flawed premise, a standard slab-on-grade foundation was specified and designed. Now, this choice would have been perfectly suitable, totally fine for the reported stable conditions, but it was entirely, fundamentally unfit for the actual subsurface reality.
Because of the hidden clay.
That hidden clay lens, unseen, unanalyzed, was allowed to become the project's silent saboteur, quietly undermining its very foundation from day one.
And I'm guessing the inevitable outcome didn't take long to appear.
It arrived with the very first wet season, which, as we know, can expose any hidden flaw in site work.
Water finds the weaknesses.
Always. The previously undetected clay lens, upon saturation, expanded dramatically, significantly. And this expansion caused it to lose its crucial bearing capacity, which then triggered a phenomenon known as differential settlement.
Okay, explain differential settlement quickly.
Imagine one part of a building, maybe a large commercial building like this, sinking or shifting at a different rate than the rest. Uneven movement.
Right, got it.
And this uneven movement predictably led to severe structural miscalculations and just immense stress on the building's framework.
So what did that look like physically? What were the signs?
The physical manifestations of this failure were stark, undeniable. They became glaring red flags for everyone involved. Fine diagonal cracks began spiderwebbing from window and door corners, clear indicators of the immense shear stress the structure was enduring.
Ouch.
Inside, the carefully polished floors started to heave and crack, creating uneven surfaces, noticeably uneven.
Tripping hazards, even.
Potentially.
Yeah.
And interior doors, which were once perfectly aligned within their frames, now stubbornly refused to close properly. They were binding.
A constant, tangible reminder that something was seriously wrong underneath.
Exactly. These weren't just cosmetic blemishes. They were profound symptoms of deep-seated structural failure. a fundamental foundation failure.
And the financial catastrophe that followed, I imagine it went far beyond just the immediate repair costs.
Oh, far beyond. The direct expenses for remediation were staggering in themselves. This included the complex and invasive process of underpinning the compromised foundation, essentially adding new support structures beneath the existing ones. Very costly.
Right.
And also pressure grouting the soil to try and stabilize it. These direct costs alone exceeded $1 million.
Over a million just to fix the initial mistake.
Correct. But that, shockingly, was just the beginning of the financial hemorrhaging.
So there were indirect costs too.
The indirect costs were arguably even more severe, and they really highlight the broader implications of such failures for general project management, and especially for any firm considering or engaged in civil engineering outsourcing. The facility, this mid-sized commercial development, had to be partially closed for 4 months.
4 months. Wow.
Think about that, 4 months of lost revenue, massive business disruptions for the owner and tenants, and inevitably violations of lease agreements.
That must have been a nightmare, legally and operationally.
A complete nightmare. These kinds of profound delays don't just affect the immediate project budget. They create a ripple effect. They often trigger broader project failures, transforming what should have been viable, income-generating assets into long-term liabilities that actively drain resources.
So the initial saving on the geotech investigation ended up costing magnitudes more.
Exponentially more. This anonymous case study stands as a stark, undeniable reminder of that exponential cost difference between proactive, preventative action and reactive, after-the-fact repairs.
And you're saying this pattern, cutting initial costs only to pay way more later through rework and failures, it isn't isolated.
No, unfortunately not. It's a widespread, systemic problem across the entire civil engineering industry. We see a similar sobering trend even when we look at national infrastructure. Many U.S. bridges, for example, are currently downgrading in condition ratings from good to fair.
Oh.
Now, while they're still deemed safe for travel for now, these structures are showing clear, escalating signs of deterioration. If these issues are ignored, allowed to fester, they will inevitably escalate into even more costly and complex failures down the line.
It really reflects the same core issue, doesn't it? Missing that critical window, that opportunity for timely, efficient, and ultimately cost-effective preventative action.
It's the engineering equivalent of ignoring a small leak in your roof that eventually floods the whole house. You could have fixed it easily early on.
Yeah.
And further industry analysis really reinforces this point. It reveals tangible, widespread financial impacts. Rework stemming directly from design errors like those in our case study. It forces the wasteful removal and replacement of materials, the remobilization of crews, significant schedule delays.
All adding cost and time.
Exactly. This isn't just an inconvenience. It's a process that can increase total project costs by an average of 12.5%.
12.5% just from design-related rework.
On average, yes. This figure, a direct, avoidable strike against a project's profitability, underscores precisely why that initial assumption about internal review sufficiency is not just expensive, but often devastatingly so.
It's a loss that theoretically could be avoided with the right approach.
Easily avoided with the right systems in place.
So the real threat here isn't just, say, a simple miscalculation, like specifying the wrong pipe size in one single instance, although that's bad too.
Right.
It's actually a deep-rooted systemic vulnerability in how projects are conceptualized, planned, and executed, right from their very inception.
That's the heart of it. When there's no robust, integrated framework designed specifically to detect and correct these early, seemingly small errors, those minor oversights are simply allowed to grow.
They compound.
They compound, and eventually they become unmanageable, budget-breaking, or even safety-compromising problems.
And for any organization engaged in civil engineering outsourcing, this systemic vulnerability is a critical factor to consider.
Absolutely critical. It highlights the absolute necessity of integrating clear, systematic, and proactive processes into every single stage of project delivery to ensure success. You need confidence in your partner's processes.
Which brings us to the solutions part of this discussion.
And this, precisely, is where a leading firm like AXA Engineers truly excels. They're shifting the paradigm from reactive problem-solving to proactive prevention.
So how do they do that? What's the core approach?
Their entire core approach is meticulously built upon several pillars: rigorous geotechnical analysis, comprehensive interdisciplinary reviews, and a deeply ingrained proactive quality assurance strategy. The fundamental goal isn't to react to failures after they've already occurred. is to identify and mitigate risks at the earliest possible stages of a project.
Building in the safeguards from the start.
Exactly. This means AXA engineers actively design safeguards directly into the very process itself. They treat risk mitigation not as an afterthought or a final check, but as an integral component of every single design decision.
What's truly fascinating here, I think, is that you're saying every decision made at AXA engineers isn't based on a guess or a hunch or even just educated experience alone, which many rely on.
Correct. While experience is vital, it's not the only factor. Each choice is rigorously backed by high-resolution data, and it's subjected to review through multiple specialized technical lenses. Their teams operate with the deep understanding that every single site, every unique project, carries its own set of nuances, subtleties.
And they're trained to spot those.
They're trained to identify even the most subtle signals, perhaps a minor soil anomaly that might be overlooked, or an unusual hydrological pattern. They recognize these as potential early warnings of what could become a costly failure down the line.
That commitment to precision and granular detail really sounds like it sets a high standard for quality in engineering.
It does. And while identifying systemic problems is an essential first step, prevention must always be the ultimate goal. This transformative approach to engineering is what truly differentiates a firm like AXA Engineers within the competitive civil engineering outsourcing space.
How does it compare to the traditional model?
Well, they fundamentally challenge the traditional model, where many engineering firms often depend heavily on a single final review, usually conducted just before plans are issued for construction.
The final check bottleneck.
Exactly. This creates a dangerous single point of failure. It often relies on just one or two senior engineers who themselves are under immense pressure facing tight deadlines.
Leaving room for error.
It leaves far too much room for critical errors to slip through undetected, potentially leading to, well, dire consequences.
That sounds like a recipe for disaster waiting to happen, especially on large-scale, complex projects. It's like having one person check the entire blueprint for a skyscraper just moments before construction begins. Seems risky.
It is inherently risky. AXA Engineers, by contrast, takes a much more robust and systematic approach. They don't just add another final check, they implement a comprehensive quality management system, a QMS. Within this QMS, meticulously defined standard operating procedures, or SOPs, are not merely guidelines on a shelf.
They're actively used.
They are deeply embedded and rigorously followed throughout every single project phase, from the initial concept right through to final delivery. It's a fundamental shift in how quality is perceived and maintained.
Okay, so it's integrated, not bolted on at the end.
Precisely. AXA Engineers has embraced and adopted this comprehensive QMS model from the ground up. It's not some superficial add-on. It's woven into the very fabric of their operations. By utilizing structured processes, checklists, and even automated checks where possible, they are able to prevent errors proactively, often before they even have a chance to materialize on paper, let alone in the field.
Wow.
This transforms quality assurance from a mere final checkpoint or a reactive scramble when something goes wrong into a continuous, integrated, and predictive practice.
And you're saying this robust, systematic approach is how those devastating design errors get methodically neutralized.
That's exactly how. It ensures superior outcomes for their clients, especially those engaging in civil engineering outsourcing partnerships where trust in process is paramount.
So now that we understand the philosophy, the why behind it, how do they actually do this on a day-to-day basis? Let's drill down into some of AXA Engineers' truly battle-tested methodologies.
Okay.
Because this is where the rubber meets the road, right? Where theoretical concepts become practical excellence. First up, you mentioned combating code compliance oversight with cutting-edge technology. What's the common problem there?
Well, the common problem is often gaps in code compliance. These can frequently arise just from simple human error, maybe manually referencing outdated standards or struggling to keep pace with the sheer volume and speed of regulatory changes across different cities, states, even countries.
It's a massive challenge for any firm, especially one operating across diverse regions. Keeping up must be tough.
It is. So AXA's solution to this pervasive problem is both elegant and incredibly robust. They mandate the consistent use of fully licensed, consistently updated Autodesk software, specifically Civil 3D.
Okay, Civil 3D, but lots of firms use that, right? What's different?
It's how they use it and integrate it. This isn't just about having the latest version of a program. It's treated as a fundamental strategic quality control measure. By fully integrating it with Building Information Modeling, or BIM, workflows, Civil 3D automates critical compliance checks. It can perform clash detection between proposed designs and existing infrastructure automatically.
Ah, so it flags potential conflicts.
Exactly. And crucially, it means their design libraries, their calculation parameters, and specific regulatory adherence checks within the software are perfectly aligned with the absolute latest municipal, state, and federal regulations. The updates are managed centrally.
So it takes the guesswork and manual checking out of it.
It significantly reduces the potential for human error. It eliminates laborious manual cross-referencing of code books or websites, and it ensures regulatory adherence right from the outset. That's a critical factor for any civil engineering outsourcing partner who needs to navigate a complex, sometimes global regulatory landscape reliably.
That makes so much sense. It's about leveraging technology not just for the design itself, but as a dynamic guardian against those tricky human errors that can snowball.
Precisely.
Okay, next methodology. Let's talk about ensuring flawless material selection. You mentioned this is another area notoriously prone to costly mistakes.
It really is. Selecting the wrong grade of steel, maybe an incompatible concrete mix for the environmental conditions, or even a suboptimal aggregate. These can have disastrous long-term consequences on durability and safety.
So how does AXA engineers tackle that level of precision? It seems like there are infinite choices.
AXA Engineers employs a truly innovative model here, something quite unique, a dual-team working structure that operates across two distinct shifts.
Two shifts. How does that help with material selection?
Well, it creates a fundamental advantage, especially in the context of civil engineering outsourcing, where teams might be geographically dispersed. This unique structure provides a constant, real-time peer review process. Here's how it works. Designs and detailed specifications, including material choices, completed by one team during their shift, are immediately and systematically vetted, scrutinized, and verified by the incoming team on the next shift.
So fresh eyes are always looking at the work just done.
Fresh, expert eyes. And this isn't just a casual glance over coffee. It's a rigorous, methodical re-examination. It creates a continuous, unbroken loop of verification and validation.
A continuous loop of verification that sounds absolutely brilliant. It's like having a built-in second, third, and maybe even fourth set of professional eyes on everything all the time,
That's the idea.
ensuring nothing slips through the cracks, even across different time zones if they're working with international clients.
Exactly. This meticulous process ensures that every single material choice, every specific component specified, is rigorously challenged, cross-referenced, and validated against all the project requirements. This includes checking against detailed geotechnical data, specific structural loads, long-term environmental factors like corrosion potential, and even constructability considerations. Can this actually be built efficiently with this material?
And this happens before it's finalized.
Yes, before it is ever finalized and incorporated permanently into the design documents. This meticulous, multi-layered approach is absolutely key to de-risking projects, mitigating those unforeseen issues, and it really stands as a powerful testament to AXA Engineers' unwavering commitment to delivering excellence in civil engineering outsourcing.
That level of relentless scrutiny must make an enormous difference in the ultimate reliability and longevity of a project.
It demonstrably does.
Okay, now let's pivot to a particularly pressing and, well, evolving issue in our modern world, addressing environmental impact neglect with resilient design. You mentioned the modern challenge here is deeply rooted in the concept of non-stationarity. Can you unpack that term a bit?
Yeah.
What does non-stationarity mean for engineering, and why is it so critical right now?
Sure. Non-stationarity is a really profound concept primarily from climate science, but it has massive implications for civil engineering. It essentially refers to the scientific consensus that historical climate and weather data, the data we've traditionally relied upon for decades to design infrastructure, are no longer reliable predictors of future conditions.
The past isn't prologue anymore, climatically speaking.
Precisely. For example, designing a culvert or a bridge for a 100-year flood event based solely on rainfall records from the 20th century. That's no longer sufficient or safe in many regions. The climate is changing. Extreme weather events, floods, droughts, heat waves are becoming more frequent and more intense. Past patterns simply don't guarantee future performance anymore. It's a fundamental shift in how we absolutely must approach long-term infrastructure planning.
So we can't just look backwards to predict the future when it comes to climate impacts on our infrastructure. That's a massive shift in design philosophy required.
It really is.
How does AXA Engineers' methodology directly adapt to this moving target? How do they future-proof their designs?
AXA's methodology directly addresses non-stationarity by focusing intensely on resilient design. It's a core principle. This involves several things. First, building in significantly higher factors of safety than traditional historically based methods might suggest. This isn't just about adding more concrete or steel arbitrarily. It's about a deeper, data-informed understanding of increasing risk.
More buffer, basically.
A scientifically calculated buffer. They also utilize advanced hydrological and environmental modeling. Crucially, this modeling incorporates projected future climate scenarios from reputable sources like the Intergovernmental Panel on Climate Change, the IPCC reports, and regional climate studies.
So they're modeling not just past events, but plausible futures.
Exactly. These models allow them to anticipate and account for future climate variability, things like increased peak precipitation rates, more frequent and intense heat waves affecting materials, or rising sea levels impacting coastal infrastructure. This forward-thinking approach is fundamentally about protecting assets against conditions that have not yet occurred, conditions that may lie far beyond historical norms.
Building for tomorrow, today?
That's the mantra. Ensuring assets remain viable, functional, and safe for their entire intended lifespan, which is absolutely paramount in strategic civil engineering outsourcing, where clients expect long-term value and reliability.
That's a truly forward-thinking and frankly responsible approach, ensuring that what's built today can actually withstand the increasing challenges of a changing climate.
It's becoming non-negotiable.
Okay, finally, let's talk about mastering project timelines. This is a huge one. A pervasive issue across the entire industry, a notorious factor in budget overruns, and honestly, a headache for everyone involved, from clients to engineers to contractors.
The bane of many projects.
Indeed. How does AXA's dual team approach, which you mentioned for quality control, also help ensure uninterrupted progress and keep projects on schedule? It seems counterintuitive that splitting work helps speed.
It's actually a key benefit. The dual team model directly counters this pervasive issue of project timeline mismanagement in a couple of ways. Firstly, by operating across two distinct shifts, a project's progress simply doesn't halt at the end of a standard 8-hour workday. Handover protocols ensure continuity.
So it's almost like a 16-hour workday for the project itself.
Effectively, yes. It creates a seamless, almost 20/47 workflow in some configurations, ensuring rapid project advancement, especially during critical design phases. Secondly, and this is huge for civil engineering outsourcing, it significantly facilitates near-constant communication with clients operating across different global time zones.
Right. No waiting overnight for answers.
Exactly. It allows for much quicker feedback loops, faster decision-making, and resolution of queries. There's always someone available during the client's working hours.
That must compress schedules significantly.
It does. This innovative approach effectively compresses project schedules without sacrificing a single ounce of that quality or precision we talked about earlier. That dual-team review is still happening.
So you get speed and quality.
That's the goal. This inherent efficiency and accelerated delivery schedule is a massive draw for organizations considering civil engineering outsourcing. It offers not just quality and resilience, but also impressive speed to market, which is often a competitive advantage.
Okay, so we've covered the problems, the assumptions, and AXA engineers' specific methodologies, the tech, the dual teams, the resilient design, the timeline management. But beyond all these impressive processes and battle-tested methods, what about the real-world impact and the unwavering trust that AXA engineers seems to have cultivated?
Right.
Because at the end of the day, systems are only as good as the people who implement them, right? And the actual results they deliver for clients.
That's a crucial point, absolutely. The efficacy of AXA's rigorous system isn't just theoretical on paper. It's thoroughly validated by practical, measurable outcomes, both internally and externally. Internally, this meticulously process-driven environment, while demanding, also creates the optimal conditions for profound professional growth and remarkable operational stability within the firm itself. Well, when processes are clear, quality expectations are high, and support systems are robust, engineers can focus on engineering. It fosters a culture of excellence in learning. This internal success, where professionals feel empowered, are continually learning, have clear standards and career paths, translates directly into external quality. It's not a coincidence.
Happy engineers do better work.
There's definitely truth to that. This is precisely why AXA Engineers has achieved an independently verified 97% employee satisfaction rate.
97%, that's extraordinary, especially in a high-pressure field like engineering.
It is an extraordinary figure in any industry, let alone one like civil engineering.
Yeah.
And this satisfaction is maintained while simultaneously upholding the absolute highest quality standards in every single output. They don't compromise quality for satisfaction or vice versa.
That 97% figure really speaks volumes about the culture, how they value their people, and I imagine that has a direct, tangible impact on the quality of work delivered to clients.
Absolutely. Think about it. A committed, highly satisfied, and importantly, stable team of professionals is arguably the most effective, most consistent line of defense against costly oversights, errors, and project delays. When engineers feel valued, supported by strong processes, and have a clear understanding of best practices, they bring an unparalleled level of dedication and attention to detail to every single task.
Less turnover means more consistency, too.
Exactly. This high internal satisfaction and low turnover is a profound testament to AXA Engineers' reliability and consistency as a premier civil engineering outsourcing partner. Clients benefit from that stability,
Yeah.
and this internal success is further reflected and amplified by significant external validation from highly respected industry authorities.
Okay, so when we talk about external validation, we're not just talking about satisfied clients, though that's obviously paramount. We're talking about recognition from industry bodies.
Yes, specific recognition for organizations that truly understand the intricate nuances and demands of the civil engineering industry.
Such as?
While AXA Engineers has garnered significant, publicly recognized validation from industry leaders and authorities. For instance, they've received specific recognition from organizations like Autodesk, the makers of Civil 3D we discussed, acknowledging their advanced use of the technology, and also from publications like World's Leaders magazine. Both have acknowledged AXA Engineers for its industry-leading processes, its innovative application of technology, and its unwavering commitment to technical excellence in project delivery.
That kind of independent third-party recognition is powerful.
It speaks volumes about their credibility, their consistent performance, and frankly, their leadership position in the global civil engineering outsourcing market. It's a clear signal that their methodologies aren't just effective in-house, but are actually setting benchmarks for the entire industry.
So listening to all this, it's really clear this isn't simply about outsourcing discrete tasks like drafting or specific calculations, or just finding a more cost-effective option for engineering services somewhere else. It's much more strategic.
You're absolutely right. AXA's model completely transcends traditional outsourcing paradigms. It's about seamlessly integrating a proven, battle-tested system encompassing quality control, innovation, resilience, and comprehensive risk mitigation directly into a client's workflow.
Becoming an extension of their team, but with enhanced processes.
Precisely. This means partnering with a firm like AXA Engineers provides direct access to this entire proven methodology for comprehensive risk mitigation. It ensures project integrity from the initial concept sketch right through meticulous completion, and even considering the ongoing operational life of the asset.
That sophisticated integrated partnership sounds like the true value proposition here, especially for anyone seriously considering strategic civil engineering outsourcing.
It is. And as the industry faces ever-increasing challenges from intense global competition, the escalating impacts of climate change we discussed, and the critical need to revitalize aging infrastructure worldwide, forming such strategic high-trust partnerships becomes not just beneficial,
But essentially,
I would argue, yes, truly essential for long-term success and maintaining a competitive advantage.
okay, as we wrap up this deep dive, let's circle back to that central, often unspoken truth we started with. The most expensive assumption in civil engineering truly is the belief that your current process, whatever it is without silent systemic flaws. The financial costs, the reputational damage from design errors, these aren't some random, unpredictable risk that you just hope to avoid by luck.
No, they're often predictable.
They are, in fact, the predictable outcome of identifiable procedural gaps. Gaps that can and absolutely should be corrected proactively.
And the profound solution, as we've seen throughout this discussion, isn't simply to work harder or to put in more hours checking things at the last minute, though dedication is always valued. It's about intelligently integrating a dedicated, systematic approach to prevention, building a robust framework that catches errors at their infancy, builds unparalleled resilience into every stage of the project, and drives continuous improvement through feedback loops.
And AXA Engineers embodies this powerful solution.
They do. They offer a clear, proven pathway to unparalleled project integrity, enhanced reliability, and crucially, profound peace of mind in the often complex and high-stakes world of civil engineering outsourcing.
So let me leave you, our listener, with this provocative thought to consider. What if your next project was not just built, but truly engineered from the ground up with a proactive system? A system specifically designed to eliminate those costly errors before they happen, ensure long-term resilience against future challenges like climate change, and guarantee timely delivery, thereby providing you with a definitive, enduring competitive edge in today's demanding landscape.
Imagine that confidence.
Discover the true cost savings, not just the direct costs, but the indirect ones too. Discover the enhanced confidence and the strategic advantage that come from a partnership truly committed to your success, your stability, and your future.
To explore how AXA engineers can integrate this battle-tested system into your workflow and safeguard your next project.
Contact AXA engineers today.
Thank you for joining us on this enlightening deep dive into civil engineering excellence. It's been a great discussion.
It really has. And don't forget to follow our show. And please, leave your comments. What aspects of quality assurance in civil engineering do you find most critical for your own projects? We genuinely love hearing from you.